well, we are slightly ahead of schedule, but this, I guess, is a positive news for Mr. Klaus Kopelman from ShoreLink. And we will be glad to welcome our partner, ShoreLink, to give us an overview on the onshore power supply for ships as an onshore solution for energy source, onshore solution for the ships which are on shore in the port. So Klaus, if you're ready, please give us the presentation and thank you.
Good morning. Warm welcome from Tallinn, Estonia. And thank you very much for inviting me to participate in the event. Happy to be here. My name is Klaus Kopelman, and I am representing the company called ShoreLink. And yeah, as mentioned, I am going to share a presentation about supplying power to ships from onshore energy sources. So briefly about what I'm going to tell. So first of all, what it means to have the connection point between the land and the ship, what type of different applications are needed. Then also some feasibility study analyzed to show what do the financials say about the shore power. Then also the practical examples of shore power installation, and finally some points to consider while implementing shore power. So ShoreLink in brief. So we are an engineering company which is providing tailored shore power solutions for the ports. So we have our own equipment which we develop, design, and manufacture, and our headquarters is based in Tallinn, in Estonia. And the products and services what we are providing are cable management systems and charging solutions for different type of ships. And we also provide feasibility studies so that the ports can understand what it means to have the shore power infrastructure as such, and what are the financials. And we are also a founding member of European Onshore Power Supply Association, which is gathering the companies who are doing business in shore power sector. First of all, when we're talking about connecting the land and ship, it really has to be understand how the connection can be done. So first of all, it depends on what type of ships will be connected, whether it's like ro-ro and ro-pax ferries, whether they are hybrid or fully electric vessels, or cruise ships or container ships. So the next point is of course the amount of room which is available on the quay. Sometimes there is a very narrow space available in order to make the connection between the ship and the vessel. So and the connection equipment has to be designed exactly for the specific berth, I would say. So and then of course the user friendliness and the flexibility in operation, and of course the project budget. So for example, if you are talking about the manual or automatic connection, it really is like a difference in budget. The second point is the power availability, where to get the energy which will be provided to the ship. Of course, the easiest and most convenient solution is to have the direct grid connection if there is enough power available. But in case no, then the additional battery packs can be installed, or local power generation can be done, for example, from hydrogen. So we did one feasibility study in Estonia with one ferry line as well, and then basically we have analyzed like what it means to have the shore charging there, and whether the power can be provided by the grid directly or through local power generation from the hydrogen. So basically, it's very like well-known vessel line between the land and island in Estonia. And yes, so the analysis showed that that basically, of course, if we watch the investment cost as such, the direct grid connection is much cheaper comparing to local power generation from hydrogen. But rather than that, if we are reviewing the OPEX figures, then we see that already today it is really like beneficial to have the shore charging or shore power as such, whether it's being done with direct grid connection or from hydrogen. So we could like summarize from that as hydrogen is like a new technology, it most possibly have to be subsidized in order to accelerate the usage of hydrogen. But on the other hand, it definitely there is a point to have it. So last year we did a project in the port of Tallinn where we installed 6 cable management systems. So basically like 6 connection points for the Ro-Ro and Ro-Pax ferries. There the direct grid connection were used, and the system parameters can be described as 11 kV system, 50 Hertz. So there were no static free frequency conversion used, and then per each connection point, the power which can be transferred is 2.5 to 4 MVAs. And then also the total shore power capacity which were installed during the project was 14.5 megawatts, and the project duration was fairly short, like 1 year. So and today all these connection points they are like finally implemented, and they are in use as well. And then we can also see that that in addition to the implementation and then financial impacts, the environmental benefits are also quite considerable. And then for cruise, we also we are also currently like doing the project in Norway for the cruise industry. And the conception for this project is the same. So the direct grid connection is being used. So but in this case also the frequency is changed. So I'm provided as 60 Hertz to the vessels. And in this case, the mobile connection points are used because the cruise ships which are visiting the quays are every time different, so the connection points are in different places. So it's very like easy and convenient to use such kind of equipment. And what are the points to consider while to implement the shore power? First of all, of course, following IEC 80005 standard, which is a shore power standard. This is mandatory both for the ship side and for the land side, I would say, because the important point is that both sides are capable to connect with each other, and the installations have been done based on the same principles. The next important point is finding a suitable spot on the quay. Whether it's like a stationary equipment to be installed or mobile equipment. And third important point is to have enough grid power or power as such. So for the power availability point of view, to have enough power to provide the energy to the ship. Also the short circuit current. The grid has to be able to resist to that and to switch on and off the big and powerful transformer units. And in case the grid is not strong enough at the port, then additional battery packs or local power generation unit can be used in order to generate the power. And we as ShoreLink, we do have the capability to provide the feasibility studies to investigate the possibilities to have the shore power in a specific port. And yeah, so by the end, yes, bringing back the slide which I showed in the beginning to show you again the different like products and services that we have. So we have by now developed the connection points, the cable management system, for very different type of applications. And whether it's like a RoRo and RoPax, cruise ships, electric vessels, or container terminals. And this is basically it. Thank you.
Thank you, Klaus, for the presentation. We are well ahead of schedule. You were quite good to give us precise information. In short, we are trying to avoid the main issues with the onshore power supply. We've been receiving some suggestions and comments from fellow ports in the Baltic and other ports. There are still main issues with the standardization of the connectors, of the low and high voltage supply. So are you trying to overcome this solution? Are you concentrating on particular power supply and standardized connections which are to be provided to the ship owners?
Mm-hmm. Yes, I mean, while we are designing our equipment, then yes, so we are trying to pay attention to the standardization as well. So that basically, I mean, the same type of equipment can be also used for other ports. Now, the good thing is that the standard, the IEC 8005, which we are following, is already like giving the principles what has to be taken into account from the connectors, for example, which is connected with a ship. So that's the good thing. I think that one of the main thing is the suitable spot at the quayside, and also whether to use the stationary equipment or mobile equipment, because as you said, you know, different type of vessels are visiting the same berth. So how to be able to provide the equipment which is suitable for every type of ships. Now, this is indeed the main challenge, but I think that by the time the standardization could be take place as well.
Okay, thank you for the answer of this question. That definitely will be of assistance to us. I've got information. There is a question on the YouTube live chat. Will you be able to answer it now, as we have a few more minutes? It's a question from Madly Kopti. You mainly introduce the shore side, Klaus, but based on your experience, what are the main shortcomings from the ship's side?
Mm-hmm. Yeah, for the ship side, now, I mean, no, we don't have, of course, that long experiences for the ship side, as we are mainly focusing on the shore side. But no, for example, if we are taking the hybrid or electric vessels, then the question is, you know, where the charging equipment will be installed and whether the charging will take place in AC current or DC current. So and also, no, of course, one thing is, designing the vessel from scratch and doing it fully electric, but also the other main subject is to make the conversion on the existing ferries and making them electric. So and then the main challenge is to find enough free space where to install the battery packs, where to install the charging equipment. And yeah, again, it depends on how the charging is taking place, whether it's AC or DC, and also the number of equipment depends on that.
Yeah, I understand. So basically, it's critical for you as a supplier of this infrastructure, OPS, to work closely with the ship owners, basically to synchronize these installations to be sound and safe and not to get wasted somewhere in between the standardization. So close work with the ship owners when the ships are retrofitted in order to avoid such complications. Well, that says it quite a lot now. Klaus, thank you once again for your presentation and the support from ShoreLink, our partner.